Hello, Djordje Romanic here. Welcome to Fundamentals of Weather and Climate. In today's video, we are discussing simple topic, and that's phase changes of water. Water can be in the phase of vapor, liquid, and ice. And these three phases are related in the following way. If I have here vapor, here I put liquid, and over here I put ice. Then transition from vapor to liquid is known as condensation. Liquid to vapor, of course, is known as evaporation. How about transition liquid to ice? Well, that's called freezing. And how about ice to liquid? Of course, that's called melting. We would say ice cube is melting. Now, the question is, can we go directly from vapor to ice? Namely, skipping liquid phase. The answer is yes. And this transition, vapor to ice, is known as deposition. We would say that water vapor molecules are getting deposed on ice particle. And then can we go from ice to vapor directly without liquid phase? The answer is yes. So this arrow is also possible. And what is the name of this process? That's called sublimation. Now, why did I use different colors here? The reason is very important actually. All these arrows that are red, you will see they go from left to right. So all arrows that go from left to right give energy to the system. So if we have a volume of air, and by system I mean air, if we have a volume of air in which we have either condensation or freezing or deposition, then that volume of air will get energy from these phase changes. Whereas all arrows that go from right to left that are indicated with the blue color, they take energy from the system, namely from the given volume of air that I discussed. So if we have melting, or we have evaporation, or we have sublimation, then this process requires energy from that volume of air, what we call parcel of air, and therefore the temperature of that volume of air will decrease because energy is taken to carry out these processes. Of course, we could ask how much energy these phase changes require. And in the case of, let me see what color to use. In the case of condensation, so to transfer, or better to say, liquid to vapor, in terms of evaporation, the amount of energy is actually huge. It's 2,500,000 joules per kilogram of water. So to evaporate 1 kilogram of water, you need to provide 2,500,000 joules of energy. Well, then you can see, because the process of condensation is the same, but reversed, if you condense 1 kilogram of water, then you will release 2,500,000 joules of energy. Okay? So this quantity is called latent heat of vaporization. Latent heat of vaporization is 2,500,000 1000 joules per kilogram. What is latent heat of condensation? Absolutely the same, just in the different direction. Now, how about freezing or melting? Well, this, again, you require some energy to carry out this melting process, and this energy is 335, I believe, joules per kilogram. Namely, you need 335,000 joules of energy to melt 1 kilogram of ice. How about energy that the system gets when you freeze liquid water? It's the same amount. It's the same amount. Okay? So you can then therefore see that, for example, sublimation is just these two numbers being summed up, because the energy needs to be conserved. We could also discuss why is latent heat of vaporization so much larger than latent heat of melting. Why would this be different? By the way, before I answer that question, keep in mind that latent heat of substance is also discussed in one of my previous videos in great details. So why is this number so much bigger than that number? Well, the reason is the following. If we go back to my video on why is water so special, then you know that water is so special because it has hydrogen bonds. Now, when we go from ice to liquid, we need to disturb those hydrogen bonds to the point that thermal jiggling is stronger than hydrogen bonding. And to do that, we need to provide this much energy. However, to go from liquid to vapor, we have to sever, we have to break up those hydrogen bonds completely so that a molecule of water, vapor, can actually escape liquid and go into the atmosphere. So one more time, to go from ice to liquid, we still have the same mass of water, but we broke apart those hydrogen bonds to the point that thermal jiggling in water is stronger than hydrogen bonds that hold ice together in that hexagonal shape that I discussed in the video on why is water so special. But to go from liquid to vapor, we cannot just partially disrupt those bonds. We have to completely sever those bonds and allow a molecule to escape liquid surface and go into the atmosphere, completely being separate from liquid water. And that's why you have to add much more energy to evaporate something than to melt something. Please make sure to like and subscribe, and until next video, goodbye.